Hello everyone, Twin Beard back here at the Sleep Creek Pirate Broadcast Laboratories. I made a few changes to the FlowerPower device and I wanted to update you guys. I've been playing with some transformer type of circuit for a little bit. So let me show you what we've got going on here. Our overall circuit internally has not changed. However, you can see this coil underneath here. That's about 150 ohms ohmic resistance worth of 34 gauge wrapped on the bottom of that spool there, and then I just filled the rest of the spool with 22. So here are the terminals for our 34. Here are the terminals for our 22. Now it is in series. Or parallel, depending on your perspective. Either one doesn't matter. The leads are tied together out of phase. With our larger 26 gauge 100 and change ohm generator coil, or 50 and change ohm generator coil up here. So that's creating a pretty odd flux field, and we're taking our output here off the 34. Okay. So check this out.
The windmill stop at nothing. Let's break that speed record. Let's break that speed.
As you can see on the center trace there, directly in the center. Let me see if I can line that up for us. You can see we have some phasing with some of these kicks. It's preventing them from showing kicks. We just tweak the trigger level a little bit and we can see that. As you can see, we have one peak right on the line there and another peak just slightly inside the next division. So we are on 20 microseconds per division. Right there, which gives us a little better than 50 kilohertz for our frequency, or a little better than 3 million RPMs on our rotor. Here's our generator coil output, and I'm going to start at the bottom of this wave here. We'll align it up at the bottom, so that's not including my peaks, which are shooting all the way to there. Okay, I'm just going to go with the standard waveform and not the spikes, the big spikes. So there we go. That's 400 volts. I'm going to move this down right about there. There's 400 more volts. And 400 more. And we got about 50 or 100 on top of that. So we're at 12 or 1300 volts on our final output after going through that step-up transformer there that's built into our coil assembly, and also sharing the flux field of the rotor and the drive circuit. As you can see here, there's the output, and we're tied in right there on one side of a further transformer that's off to the side over here. Okay, so we've got that output. We've got one wire connected to our output transformer. We've got earth ground shared with our battery negative right there. Okay, well, that's the green wire. And the yellow wire connects to our transformer. We've got two secondaries on this transformer here. One has a 2 ohm resistor shunted across it, and the other has a 1 ohm resistor shunted across it with our meter in parallel. There's our amperage right there. Okay, and you can see we're on the 10 amp scale there, AC amperage. I'm going to pull the scope probe here. Well, actually, watch this. Check out that capacitive effect. Just putting my hand near the meter. Thought that was kind of odd. Put my hand near the transformer. Not touching anything, just near it. So there's some kind of capacitive coupling there with me, but not much on the motor side. So we've got like 1300 volts kicking over there. But this transformer will do a step down. So what I'm going to do is I'm going to kick channel 1 here over to AC. We're at 50 volts per division. I'm going to pull that off. Of our trace going out to our charging battery. And I'm going to connect it up over here so we can measure the voltage. At our transformer output. Now that's what's in series with the 1 ohm wire around, right, or the 1 ohm resistor right there. Okay. So let's kick it over to channel 1. And there's our voltage, boys and girls. On that. As you can see, let me just make sure. We're on 10 times there. Okay. And with the meter in line, we're now showing a slightly different amperage reading. Or the meter connected to the circuit. There's no ground connected there on the no ground. But we are getting ground right there from the other scope probe. Okay, so 1.15 times 400, 800, about 1,000. And that makes sense if we had a 12 or 1300 volt input, and we're just stepping it down a little bit, a little larger wire gauge, fewer wraps. Bingo. 1,000 volts, 1.16 amperes through a 1 ohm load. Pretty interesting, eh, boys and girls? That's going to be it for today. Enjoy. Keep hacking. No matter what you do, keep hacking. If we don't keep hacking, we'll never advance.